Concept number one, and we actually have spoken about it in the bonding topic, it's nuclear attraction. But I want to highlight it in this specific part of the course, which is the AS Inorganic Chemistry, because if you understand the trends in nuclear attraction, you understand every other trend. So periodicity will be a very, very easy topic, okay? So it's so important that you understand this concept of nuclear attraction. You also hear it as effective nuclear charge. What it is, and the definition, you just really need to understand it. You don't necessarily need to explain it, but it's the action amount of positive charge experienced by electrons. Okay, so it depends on the charge of the nucleus, which is called the nuclear charge. That's why it's important to not get confused between nuclear charge and the nuclear attraction, and distance to the nucleus. Okay, distance to the nucleus will determine, of course, the atomic radius of an atom. Okay, and we have to explain it with this keyword, shielding. So the distance to the nucleus, the more distant, the more shielding, okay? Because the shielding is the blocking of the valence shell electrons attraction by the nucleus due to the presence of inner shells. So the more shells are present, the more shielding. And this has an effect on the nuclear attraction. It's actually even more important than the nuclear charge. So the stronger the shielding, they lower the nuclear attraction, okay? Well, of course, it does increase with increasing nuclear charge, but it's important that you understand and you can visualize when you discuss any trend, these two concepts, the nuclear charge and the shielding, and which one would have a major effect on the nuclear attraction, because then the nuclear attraction will have effect on everything else, electronegativity, even the strength of the bond, any type of attraction, okay? So for the next part, we look at the why it's important. So it's important because it affects all of the properties that involve an electrostatic attraction. So think about all of the bonds, ionic, metallic, and covalent, are described in terms of electrostatic attraction, isn't it? So they're all affected by this concept. Okay. Anyway, so much more: the atomic radius, electronegativity, electron affinity, bond strength, even the oxidizing and reducing ability, which is something that we will focus on today, because we look at group 7 and redox reaction, polarizing power, tricky concept, but important for group 2. Enthalpies, you will see a lot more of this in thermodynamic in year 13, okay? But it's the essential concept. So the trend increase as the nuclear charge increases. So remember that across a period, the shielding stays the same because there is the same number of shells. So shielding stays the same, but because of increase in atomic number, there are more protons, which means that the nuclear charge increasing, shielding stays the same. The effect is an increase in nuclear charge. As we go down the group, decrease because there are more inner shells, which means that greater shielding, even though notice that the nuclear charge increases, of course, because we have bigger atoms, but in this case, the shielding has a much stronger effect. Okay, so we'll just skip the example, but we will go straight into the ionization energy. And let's also start looking at, apart from the essential concept, like what you can be asked in the exam question. So the definition of all of the enthalpies, it's fundamental. Yeah, if you're year 13, even more important, because those are part of the Born-Haber cycle, expected as 1 true mark questions. So you must be confident with the equations and the definition, okay? Ionization energy, and like all enthalpies, we've talked about them also in physical chemistry, is always the energy required to, or the enthalpy change when, or the energy needed, or the energy released. Okay, generalize the all of the definition with, I would say, the energy, the enthalpy change. And in this case, to remove 1 mole of electron from each atom in the gaseous state to form 1 mole of gaseous ions. Okay, if you have the symbol that we saw last time, the little circle with the slash, that's in standard condition. You must add that in your definition. So you have to check how many marks is your definition. So important that you don't forget that it's always 1 mole, 1 electron, and gaseous. Notice these equations, okay? So if we highlight this 1 mole of electrons, means that different ionization energies have different values of energy. Okay, in fact, the trends are fundamental. So that's why I want to highlight all of the trends that you need to know for ionization energy. So in successive ionization energy, so remove one electron, 2 electrons, and so on, increases. Okay, and you have to know how to describe that concisely, because as the electrons are removed, the nuclear attraction to the remaining ones increase. Therefore, more energy is required to remove them. This is how the mark scheme wants you to write things, very concise but consequential. Okay, so trend in successive ionization energy. So we're talking about the same element removing one electron, 2 electron, and so on. When you have to write down an equation, pay attention to which ionization energy you're talking about. Okay, if it's first, second, third, remember 1 electron at the time. So the second trend to know is down the group. Down the group decreases. Why? Well, the shielding increases. The nuclear attraction decreases, so it's easier to remove the outer electron. Also, there is a weaker attraction, okay? So if you explain in terms of nuclear attraction, it's enough. If you don't say nuclear attraction, you just say as the shielding increases, then you have to mention, therefore, it's easier to remove electrons. Why? Because it's less attracted. Once again, check the question, how many marks is it? And if it's describe, state, or explain the trend. Okay, we will see as we look at some exam questions what I mean. Okay, but shielding increases, nuclear attraction decreases, easier to remove the outer electron. Across the period, so once again, I want you to notice how this is similar to the trends in nuclear attraction, decreases down the group, increases across the period. In fact, is exactly the same, because at the end, the electron is attracted to the nucleus. That's why it would be easier or hard to remove. Anyway, across the period increases because the nuclear charge increases, but the shielding stays the same. So it's harder to remove the outer electron. Okay, there are some exceptions, and we have to analyze them. I've paused just for a second in case I'm going to pause. Oh, it's not working. So just to take a moment to breathe. If you have any questions, now is the time. And remember, the point now is not to take notes, but is that you refresh every single concept. And then if you wanted to take some notes carefully, you would rewatch this video, slow it down, and pause it in order to take notes. Okay, but otherwise, you have these revision cards. So this is how I want you to be able to interpret them, because as you notice, you will revise all of the topics in this exact way. Okay, continuing with the trends in ionization energy. We have 2 exceptions, and always think in terms of this attraction. Okay, and the trends are the exceptions are between group 2 and group 3. If you don't have a periodic table in front of you, please open that. So between group 2 and group 3, the full 2s orbital provides extra shielding that makes the p1 electron easier to remove. Here, very important that you visualize the nucleus and the electrons that fill these subshells. Okay, so notice that the electronic configuration fundamental here. If you have any doubt about it, you have to go back and check this lesson about electronic configuration. It's some of the basics that you must be 100% confident already now. The second exception is between group 5 and group 6, because one electron in P4 it's paired, and this causes extra repulsion, which makes it easier to remove. Because remember the rule that the subshells are filled first and then they're paired up. So those are the 2 main exceptions for, and they recur along the periods. Okay. Next, the concept of periodicity. At the end, it's very, very simple to these trends in nuclear attraction. Okay, so the atomic radius decreases as we go down the group, and I just want you to think about how is atomic radius related to nuclear attraction, and then you would be able to work out the trends very easily. Okay, but let's look at this note. As the nuclear charge increases, but the shielding stays the same, the outer electrons are more attracted to, so the atom decreases in size. Visualize it. Yeah, more protons in the nucleus, same shielding, therefore there is a stronger attraction. Therefore, atomic radius decreases. The next trend, melting point. Okay, here we needed to take a moment to revise the concept of bonding because it is actually, the foundation concept here. So notice the trends. And here, there's nothing to remember. I always want you to work it out by, using the foundation knowledge that you have. So from sodium to aluminum, there is they all have metallic bonding, and it increases. Aluminum should be just a little bit higher than magnesium. It increases. Okay, I want you to think about why in terms of what is melting point. So it's, the energy required to change the state. Yeah, so it's the temperature at which there is a change in state. Okay, and it depends, of course, on the bond strength. And guess what the bond strength depends on? Depends on the nuclear attraction. In fact, metallic bonds, sodium, magnesium, and aluminum, they all have metallic bond. The higher the positive charge of the metal ions, the more delocalized electrons, therefore the stronger the bond. Once again, there is more attraction between positive ion and the delocalized electrons, therefore more energy required to break this bond. Again, if you have to explain it, if it's 3 marks, you would have to always say therefore more energy required too. Okay. Silicon, it's the highest because it has a giant covalent lattice. Also carbon, of course, would be the highest of its group. Same reason. Then, slightly different is from phosphorus, sulfur, and chlorine because they are all simple covalent molecules. But here, yes, you do need to remember that phosphorus exists as before, sulfur as S8, and chlorine as Cl2. So it all depends on van der Waals forces, which depends on the number of electrons. They are non-polar molecules. This means that it only depends on the size of the molecule. Of course, notice S8 would be the largest molecule, so would have the largest London dispersion force, or van der Waals force, therefore slightly higher the boiling point. And then argon, of course, is the lowest because it's a single element. So melting point, I am just recalling everything that you've learned about bonding applied to this topic, which is periodicity. Okay, and this is actually it. So notice how all of these concepts like successive and it all depends on this concept of nuclear attraction. So I really want you to learn to visualize this concept and how it affects all of these trends. The trends down group 2 element, I think you would be able to explain all of them because you've studied all of these concepts already. So it's nothing new, you just have to apply it slightly differently. So think about it. Atomic radius increases. You know that. Why? Well, we talked about nuclear attraction already. Same. Melting point. You need to think about the metallic bonds and why does it get weaker once again relative to this nuclear attraction. Ionization energy, we talked about the trends on the group. Reactivity increases. Okay, the reactivity, well, it's very similar, it's always at the end down to this attraction, but you have to be able to explain it in terms of the actual reactivity, which is reactivity increases. Why? It's easier to lose 2 electrons because again, they're further away from the nucleus. Okay, so here you will explain it in terms of how in terms of this shielding and once again the attraction to the nucleus. Okay, but the more tricky things about group 2 are this. So in order to remember these trends, you must understand it. Okay, because I think it's really counterintuitive. That's why I do this explanation today, because you must have very clear this concept. So the solubility of hydroxide increases, but carbonate, sulfate, nitrate decreases. the thermal stability of hydroxide, group 2 hydroxide, of course, decreases, but carbonate, sulfate, and nitrates increases. As you can see, is the opposite trends from hydroxide and carbonate, sulfate, and nitrates. And I think if you don't understand the logic, for me, it would be very confusing to remember it. So the other one to remember is the nitrates of group 1. Yeah, they thermally decompose like group 2 elements, but just lithium, while the rest of the group doesn't fully decompose. And well, you have to know the equations. One way to remember this thermal decomposition is that all of these carbonates, sulfate, nitrates, at the end they want to get to the simplest compound possible, and that in that case would be the metal oxide. Okay, and then you can work out a little bit the definition, even though I would suggest you to practice writing down the decomposition of nitrates and carbonates. Okay, but let's think about the reasons. It's closely related to the concept that we talked about so far, which is this nuclear attraction. But now we needed to discuss it in terms of polarization. So polarization, think about a polarity, polar, we talked about it in intermolecular forces. So if you think about an ionic bond, which is what these bonds are, is an electrostatic attraction between oppositely charged ions, right? So we have two spheres, one positive, one negative, and they're attracted. However, if the positive ion it's very highly charged and the negative ion it's very large and it has a lot of electrons, something happens, which is this polarization. Polarization causes distortion, and distortion is what weakens the bonds. This is called the covalent character. This means that the weaker the bond, the easier it is to break. And this will link to the trends. Now, I want you to look carefully at this diagram. As you can see, magnesium, it's smaller. It has what we call a higher charge density. You must look at the video about charge density if you don't remember the concept. While calcium, as you can see, it's a larger ion. So this 2+ charge, it's spread over a larger volume. So it won't cause distortion as much as magnesium would do. Okay? So I hope you understand this concept, because this is what determines the difference. So look at this. The higher the nuclear attraction, the higher the polarizing power. Magnesium is the highest one, barium is the smallest. And the larger the anion, the easier it is to polarize. So sulfate, it's the biggest anion, it would be the most polarizable. So notice that hydroxide, it's very small, it doesn't have many electrons. It cannot be polarized, which means that this distortion doesn't occur. Instead, it just follows the strength in the bond. So let's go back at this strength. Sorry, what am I doing? Where am I going? Here. Hydroxide, the solubility increases as we go down the group. Why? Because it will be easier to break this metal hydroxide bond as you go down the group. Why? There is weaker attraction. While carbonate, sulfate, and nitrate, the solubility decreases. Why? Because it's harder to break these two ions apart. Why? Because there is less distortion. And it's a difficult concept to grasp, but if you fully understand it, then it will be easy to remember this trend. Okay. Thermal stability, it's, again, it's all relative to how easy it is to break this bond between the ions. Okay, so same concept. One point that I want to make is the pH, remembering that if the solubility increases down the group, so does the pH, because of course it releases more hydroxide ions. And the hydroxide ion is what determines the alkaline pH. Okay. So, one thing, why group 1 elements has a similar trend. Once again, it's because of this, let's call it charge density if you want, not at this point. At the very top of the group, the positive ion is very small, very highly charged. As you go down the group, the ionic radius increases, so the charge density is lower, meaning that there is less distortion. Okay, so these concepts require you to take these revision cards and actively explain it until it really clicks and you feel really confident that you can visualize, the size of these ions and the attraction between the opposite charged ions, which then determines, if it's easier, harder to break, if there is any distortion. So we does take practice, use these revision cards as help for this active recall. Okay, and here it's a little summary, but it's important that you do take your time to explain it and understand it. So in the chemical reactions of group 2, you must be very confident. So just you have to know how to write down equations, the state symbols, and of course, the most important will be the observations. So state symbol linked to the observations. And then the type of exam question that you might get here are more of how the observation will be different if there was like another metal, and here would link to the reactivity. Okay, so the keyword here would be like effervescence to explain the physical change that you can observe, as well as the vigorosity. So more vigorous would be the nice term to use to describe the trend in the reactivity. Okay, and we will practice in our exam paper how to write down some of these reactions. But as you can see, group 2, that's kind of it. Yeah, be confident in writing down the equations, but they're metals, they do react as metals. The tricky part, of course, of this, how to describe these thermal stability and solubility, but I hope you can now link it more now that you understand and you're more confident with this concept of nuclear attraction. Okay. Let's look at definition of acid and bases. In year 13, it's a very big topic, one of the most challenging in terms of calculations, okay? But the essential concept is super important, and we can simplify a lot of concept. And for example, this conjugate acid base pair, if you're year 13, remember this, you must be confident with the definitions, okay? So acid, proton donor, base, proton acceptor. And as long as you're able to observe these transfer of protons, you will be able to determine neutralization reactions and find these conjugate acid base pair. Okay, just to have a little summary and revision. Strong acid completely dissociated. We know we show it with the 1 arrow, and then we can distinguish between monoprotic, diprotic, depending on the number of hydrogens that are removed. Weak, partially dissociate, sets up an equilibrium, so it doesn't release all of the H+ that it can. Okay, so if you think about the effect this would have on the pH, would be if we have 2 acids of the same concentration, of course the pH would be lower for a strong acid because it releases more H+ ions. Okay, base. Proton acceptor, remember we distinguish 2 different ones. Water insoluble is a base, while water soluble would be an alkali. Okay, so remember the trend in solubility of group 2 compounds, because it does help distinguishing between some alkali and bases. Okay, I would highly suggest you to remember some of the formula of common acids and common bases, because you might be asked to write balanced chemical equations about this. Okay, so neutralization reactions, here I only have ionic equations. If you don't remember how to write ionic equations, you must go and practice and look at the video about ionic equations, because neutralization reaction, think about it, what is the product, the key product of neutralization reactions is water, okay? Because acid, proton donor, base, proton acceptor, what accepts the proton will be normally the the part that has oxygen, okay? In fact, with metal oxides, notice we have H plus and, oxygen to form water. Hydroxide, well, this should be a negative. Why is it a positive? This should be a negative. Carbonates is the different one that forms also carbon dioxide. Very important. This metal carbonate, it's a very important reaction when we look at organic synthesis, because if we have an acid, we can react with a carbonate to actually determine if it's an acid or not. Because the other reactions, notice, that don't really give any physical observation, but the carbon dioxide, yeah, we see it as effervescence. And anyway, this carbon dioxide can be tested in the lime water test. I just want you to notice, because you will see this reaction also in organic chemistry. One very common multiple choice that you get is a list of questions, and you have to state which one is a neutralization and which is not. So very common is it's to have one of these in the options, metal plus acid. And you might remember from GCSE the displacement reactions. So if a metal is more reactive than hydrogen, it will take its place and form the salt. Okay, but it's not a neutralization because there is no proton acceptor, but the proton is just left on the side, and it will form the hydrogen gas. Okay, very important, these concepts of neutralization, but notice that is all based to this definition of proton acceptor and proton donor. So in this concept, in this topic of acid and base, we will look also just an overview of titration. And I'm not going to go through all of the steps, but just the key things to remember, because we have practiced a lot already. Back titration, I have a lot of extra videos about back titration. Still one of the most difficult calculations for everyone, so you must keep practicing it. Anyway, very common before one calculation, you might have a more open question where you have to describe a standard solution, like how to make a standard solution, or even the titration. So it's super important that you visualize all of these steps and you describe them in a way that if you reread it and you were in the lab, you would be able to follow them exactly. Okay, and I would suggest you to revise carefully the glassware that you use, because there are different ways to prepare a standard solution, but remember that the most important thing is to use a volumetric flask, and the bottom of the meniscum of the solution has to be on the marked line, because this is one of the measuring glassware that has the lowest percentage error. Okay, so we would be able to get an accurate concentration. Okay, and then there are some steps that you must take, for example, rinsing the funnel with water bottles so that you make sure that all of the liquid has been transferred. Okay, and then when you're close to the meniscus, just add the solution with the pipette, then with the stopper, and mix it. Okay, so those are all steps that if you have to describe this preparation, will give you marks. For the titrations, never don't forget the indicator, but it's harder to forget a step if then when you reread it, you can visualize yourself in the lab doing it. Okay, do this practice of visualizing when you want to describe an experiment. Okay, I'm gonna skip through the calculation because we did some practice last time in physical chemistry in the amount of substance topic. Okay, and this is the end of acid and bases. As you can see, just foundation concepts that are fundamental for the next topic in year 13. Okay, this topic of redox. The definitions are very, very important, and they will help you in many topics, not just these AS of redox, but also organic chemistry, and also in the electrode potential calculations and the topic, and even transition metal in year 13. So very, very important. Definitions: oxidation, gain of oxygen, loss of hydrogen, loss of electrons. Also an increase in oxidation number. I don't like to remember this because, to be honest, on top of my head, I don't remember it, even though it makes sense, oxidation, increase in oxidation number, but you can just work it out, the oxidation number, more easily. Okay, the gain of oxygen and loss of hydrogen is very important when we look at organic chemistry and redox reactions, because it would be the easier way to detect it. While if we look, for example, at metal reactions, the changes in oxidation number and noticing the transfer of electrons is probably easier. Okay, remember, easy way, oil break, oxidation is loss, reduction is gain of electrons. Okay, so those are the two important definitions, but it just requires careful observations of the reactions that you're given, and observe it and see how you have to analyze it, if it's in terms of oxygen and hydrogen, or if you have to work out the oxidation number and therefore the difference in charges of products and reactants. Okay. Another very important definition is the definition of oxidation number. I think it's unnecessarily complicated, but let's just state it. Number of electrons that have to be added or removed for an ion to become neutral. At the end is the same as the charge. Okay. In fact, elements 0 because they don't have a charge. Group 1 elements always +1 because, as we know, they only react in that specific way. Group 2 elements +2. There are some exceptions of, no, actually not, yeah, some exceptions, for example, of oxygen, which is always -2 unless is in hydrogen peroxide, which is -1. Hydrogen always +1 unless it's in it's called the hydride ions. A-level students, do you remember where this is, where we've seen a hydride ion? Reduction of carbonyls. Okay, just so that you think about it. And then the other exception of oxygen is when it's attached, when it's bonded to fluorine, because fluorine is always -1. Okay. Then, if we have a compound, the sum of oxidation number is 0. Okay. While if it's if a polyatomic ion, the sum of oxidation number would be the charge of the ion. Okay. And here we have a couple of examples, but we will see it in the exam practice. Third important concept of redox is oxidizing reducing agent. So oxidizing agent, and just find a way that it's easy for you to remember. For me, is oxidizing agent, a known agent. It's something that makes someone else do something. So oxidizing agent, it's what is reduced. Reducing agent is what is oxidized. You can remember like this, or maybe you remember it as oxidizing agent increase the oxidation number of another atom. Reducing agent, decrease the oxidation number of another atom. Find the way that it's easy for you to remember. Okay, in fact, notice how in this example, zinc it's reduced because it gains 2 electrons. It goes from an oxidation number of +2 to 0, meaning if it's reduced, it's the oxidizing agent. So very common questions here would be to explain if it's a redox reaction by using oxidation numbers, or find the oxidizing reducing agent in a reaction. So it's important that you learn how to observe the chemical these redox reactions. Okay, to find the half equations. And I'm gonna go through the two methods, okay, and because we must be confident with it. And a very common exam question is also redox titration. Maybe it's like a back titration, but with redox reaction. So the first few marks could be writing down the half equations. So it's like 1 or 2 marks in the paper that could be kind of anywhere. Okay. So the method that I like the most is to balance the charges, because sometimes finding oxidation number of polyatomic ions is a bit more complicated. Yeah, while you can always double check if it's right or wrong by balancing the charges. But the first most important step is that you balance the elements. So if you have the unbalanced half equation, and very important actually, to write the half equation, you sometimes you're given the full equation, and it's very important that you take one element, okay, and how it's in the reactant and how is that in the product, and then you balance it, okay? Because remember, half equation is the change of one element at the time, okay? Very important. So manganese, so we write it this way, and then to balance oxygens, we add water. But this unbalances the hydrogens, so we add H plus on the opposite side. And the half equation will look like this. Now, balance the charges by adding electrons. What I mean is, if you look at this with, like, ignore the electrons on this side for now, but this is the equation, with the elements all balanced. If you look on the left-hand side, we have a total charge of 7 plus. I'm going to repeat it, depends, 7 plus because, so 7 plus, because we have 1 minus and 8H plus, while on this other side, the water is neutral, so it's going to be 2 plus. And you must balance the charges of these two sides by adding electrons. Okay, how to do that? Well, you add 5 electrons on the left-hand side. And there we go, your half equation is balanced. If it's a very simple half equation, for example, we have just like an element, without, is not a polyatomic ion, then you can just look at the charges. So again, write and balance half equation, and then it might be easier to look at the charges. Like ion, it becomes a 2 plus ion. What does that mean? Well, it must have lost the 2 electrons. You write them on the loss side, which is the product. Okay, different approaches, but yeah, the rules are always the same. Make sure that you have balanced elements before you add electrons or work out oxidation number. Okay, always write down an equation, balance it. That's how it's supposed to be. And in a nutshell, this is the whole redox. I do it now, this topic, because understanding fully redox really helps in understanding group 7. Okay. Group 7, trends linked once again to the topic of periodicity that we talked at the beginning. Okay, so I'm just going to state them. Notice that they're nicely summarized here. Atomic radius increases, boiling point increases, electronegativity, very important concept, decreases, reactivity decreases. Now, one thing that I want to highlight is that all of this are diatomic molecules, so they're small covalent molecules. This means that the intermolecular forces affect the boiling point. Okay. One trend that I didn't talk about in periodicity, but I am mentioning it here, is the electronegativity. Do you remember the definition from a physical chemistry lesson? Is the ability of an atom to attract electrons toward itself in a covalent bond. We have nonmetals here. They form covalent bonds with other nonmetals, and if they have a strong enough nuclear attraction, they may attract the electrons in this covalent bond, forming polar. Fluorine is the most electronegative. Maybe you can link it to the trend in nuclear charge. In an effective nuclear charge. And reactivity decreases. Why? Because remember, they gain electrons, causes group 7, and as there are more shells, the electron to gain is less attracted to the nucleus. Notice how I'm always talking about the attraction. Okay, you do need to be familiar with the colors. So here you have a little summary that you need to know. And we will have a look also how this is important for testing for halogens, okay, as well as designing experiment to either, for example, finding the rate of a chemical reaction, or just as a test to detect which halogen is present. Okay, now, as we just discussed the redox, I want you to think a moment about these redox trends, because it's not anymore like as we go down the group, the reactivity decreases because it takes more energy to gain the electrons because it's less attracted. Yeah, this was kind of our older definition and explanation, because now we can explain it in terms of redox. In fact, fluorine is the strongest oxidizing agent, while iodine is the weakest oxidizing agent. Think about it for a moment. oxidizing agent. It's the one that gets reduced, so gains electrons. Oh, fluorine is the smallest of all of these atoms. It can gain the electrons more easily. So we're adding into this explanation, or better, we are explaining these redox reactions in terms of oxidizing, reducing agent. And notice that at the end is all relative to the nuclear attraction. Let's think about the reducing ability of negative ions. So fluoride ion is the weakest reducing agent. Why? Well, what does a reducing agent do? The reducing agent is the substance that gets oxidized, loses electron. For fluorine, it's the hardest to lose electrons. Why? Once again, because of its size, smaller ion, stronger attraction. Okay. There is nothing to remember here. If you understand the key concept of redox, then you can just interpret it. And very common multiple choice question about which one is the strongest reducing oxidizing agent, okay? Or explain, the redox reactions. Yeah. So redox reactions of group 7, we have one specific type, which is called the disproportionation reaction. The most common exam question you can get is explain in terms of oxidation, in terms of change in oxidation number, why this is a disproportionation reaction. Okay, so let's look at it in this way. We have two different types. We have chlorine with water or sodium hydroxide that will form the chlorine with this charge, or when chlorine reacts with hot sodium hydroxide, it will go to a higher oxidation number. So notice that disproportionation, the same element is reduced and oxidized. Okay, so we will see that the change in oxidation number is chlorine is 0 because it's an element, and then it's bonded to hydrogen. So we know hydrogen is +1, chlorine must be -1. While when it's bonded to in this chlorate, this hypochlorous acid, also called chlorate, chlorine, it's +1. Notice how the name corresponds to that as well. Very important, sometimes you might be asked to name this correctly. You must add the oxidation number of the element that changes it, which is chlorine, +1 here, +5 over here. Okay, so this is the reaction. Now, to expand these redox even more, let's look at, it's a little summary of this concept of reducing agents. So there are a lot of equations here, but I want you to just follow along what I'm saying. As we know, between the trend in reducing agent as we go down the group, it increases because iodide, it's a much stronger reducing agent in the sense that it will lose electrons more easily compared to chloride ion. Why? Same concept of this attraction of this nuclear attraction. Iodide is a lot weaker. So notice how chloride, it doesn't even cause a change in oxidation number of sulfur, which is the element to take into consideration here. Bromine, the bromide ion, it's a stronger reducing agent than chloride. In fact, it will extend this reaction to form a sulfur dioxide. So we're changing the oxidation number. In the next slide, you will see the change in oxidation number. You don't have to worry about working it out right now. But then notice how iodide, it reversed even the oxidation number of the sulfur to a negative charge when it's, from sulfur in the sulfate to H2S. And let's look at the change in oxidation number because we have a little summary here. And notice that in sulfuric acid, sulfur it's +6, and in the reaction with iodine, it would go to -2. So notice how the stronger the reducing agent, the further the reactions will go. And I think this is the way, if you understand this, then if you're asked to write one of these reactions or to explain it, I think it simplifies it a little bit. You do need to be aware of what you can detect in this reaction, that it's distinctive. And with halogen, there are always going to be a color change. Not always, but there might be a color change if you're changing between the element of, the halogen and a halide ion. In fact, if we have bromine, it would be like this brown fumes as well as the HBr, white fumes if it's hydrochloric acid because it's an acidic gas, okay? Purple gas for iodine. Then what else is distinctive that changes? Sulfur is a yellow solid, and the H2S, it's this bad smell, it's kind of rotten egg. Okay, so there are some distinctives. So if you have to describe the observations, always look at what is changing state and think if there is any color change or anything distinctive that you can mention in this reaction. Okay, it would be a very specific exam question, so you would know. But very important to just learn this, what to notice in a chemical reaction. Okay, so just a last part, which is the test for halogens. The reagent is silver nitrate, acidified, so with nitric acid. And the second test will be ammonia. So the first test is, and here we have the precipitation reaction, the ionic equation, where we have silver as an ion reacting with the halide ion and form a precipitate. This precipitate, it's not soluble for fluorine, that's why it's not in the list. The color is different, so notice the trending color as we go down the group. It gets darker, just like the color of the halogen itself. White, cream, and yellow. Of course, these may be difficult to observe because they're very similar in color, like in shade at least. So if you mix it with ammonia, you have an extra test. It will be soluble in dilute solution for chloride, soluble in concentrated solution with bromide, while iodide will be insoluble. So this gives you a second test to really confirm which halogen you have present. Okay, and this you will also say it in organic chemistry when you have to look at the rate of hydrolysis for nucleophilic substitution reactions. You will see this test once again, because if we time how long it takes to form a precipitate, we have a good idea of the rate of a reaction. Just to mention that, most of these topics, they're not something that you will see once exclusively, but will help you in some other topics as well. And this is it for Group 7. Okay.